Today we're going to do integration. Integration may be seen as the inverse process of differentiation. If we differentiate an expression like y is equal to 4x cubed plus 5, we get dy by dx is equal to 12x squared. So if we integrate 12x squared, we should get back to something like 4x cubed plus 5. Let's just remind ourselves about differentiation. Differentiating 4x cubed, we multiply the 4, the coefficient, by the exponent 3, and that's where the 12 comes from, and then we reduce the exponent 3 to 2, and that gives us 12x squared. To integrate 12x squared, we're going to increase the exponent, so it goes from 2 to 3, and then we're going to divide by the new exponent, so the integral of 12x squared dx, the x squared becomes x cubed, then we divide by the new power, which is 3, so we get 4x squared. But what happened to the 5? If we differentiate a constant like 5, we get 0. The reason we get 0 is that 5 is like x times... The reason we get 0 is that 5 is like 5 times x to the power of 0, because anything to the power of 0 is 1, apart from 0 to the power of 0, which is undefined. So when we integrate 0, we don't know what we get, so we call it c, the constant of integration. We don't know the value of c until we know the boundary conditions. Integrating polynomial expressions. If we differentiate an expression like y is equal to ax cubed plus bx squared plus cx plus d, we get 3ax squared plus 2bx plus c. We differentiate the expression one term at a time. Cx could be written as cx to the power of 1, and when we multiply by 1, that doesn't change the value of c, and then we reduce the exponent, so the x to the 1 becomes x to the 0, which is 1. The d term could be written as d times x to the 0. X to the 0 is 1, but when we multiply by the 0, the term will become 0. So this final term, when we differentiate, disappears. The process of differentiation was to multiply each coefficient by the exponent of the x term and then reduce the exponent by 1. The process of integration is the inverse of that, so we start by increasing the exponent of each of the x terms and then divide by the new exponent. So if we start with 3ax squared plus 2bx plus c, we increase each exponent and then divide by the new exponent. So the 2 from the x squared term becomes 3, and then we divide by the 3. The 1 of the x term becomes 2, and then we divide by 2. And then the c term is like c times x to the 0, so we increase the term by 1 and then divide by the 1. But what happened to the d term? Well, we don't know, so we have to add a constant of integration until we find the value of the constant term. So the result is the integral of 3ax squared plus 2bx plus c is ax cubed plus bx squared plus cx plus the constant of integration, which is similar to, but not identical to, the original expression. Whenever you do an integration, it's wise to do a sanity check. The best sanity check for integration is differentiation. When you've integrated an expression, always differentiate it to see you get back to where you started. Example 19.1. Integrate y is equal to 12x cubed plus 6x squared plus 4x plus 5 with respect to x. So we write it out like this. The integral of y with respect to x is the integral of 12x cubed, and so on. Now we carry out the integration term by term. So we increase the 3 to become 4 and then divide by 4. We increase this 2 to 3 and then divide by 3. We increase this 1 to 2 and then divide by 2. And we increase this implicit 0 to 1 and then divide by 1. And then we need our constant of integration. So our answer becomes 3x to the 4 plus 2x cubed plus 2x squared plus 5x plus c. Now we'll carry out our sanity check just to make sure that we're correct. So if we differentiate term by term, we're going to differentiate 3x to the 4, which is going to give us 12x cubed. We're going to differentiate 2x cubed, which is going to give us 6x squared. We'll differentiate 2x squared, which will give us 4x, and we'll differentiate 5x to give us 5. That's our sanity check. That's our original expression, so we can be reasonably confident that we are correct. This kind of integration is called indefinite integration. It's indefinite because we don't know the value of the constant of integration. So we'll just keep the letter c until we can evaluate it using the boundary conditions. Here's a table of common standard integrals, and these can be found on baseline. Now let's do some examples. Integrate cos 2x with respect to x. So we write it out like this. The integral of y dx is equal to the integral of cos 2x dx. The integral of cos is going to give us sine 2x, and then using the chain rule we divide by 2. So our answer is sine 2x over 2 plus a constant. Now for a sanity check, we're going to differentiate our answer. So the differential of sine is cosine, and then by the chain rule we're going to multiply that by 2, and the differential of the constant is 0. So our sanity check is cos 2x, the original expression was cos 2x, so we can be reasonably confident that we are correct. Now let's try integrating sine 3x with respect to x. The integral of sine is going to be minus cosine. Let's just think about that for a minute. If you differentiate cosine you get minus sine, but we're integrating sine, so we must get minus cosine. And then by the chain rule we've got 3x here, so we then divide by 3 and we have a constant of integration. So the integral of sine 3x is equal to minus cos 3x over 3 plus a constant. So we'll do our sanity check. We're going to differentiate this expression. If we differentiate cos we get minus sine, so if we differentiate minus cos we're going to get sine, and then by the chain rule we're going to multiply by 3. So we've got 3 times 1 over 3, so they will cancel, which means that our answer is sine 3x. Our sanity check is sine 3x, and the original expression was sine 3x, so we can be confident that we are correct. Now we're going to integrate e to the 3x with respect to x. So we write that out in the usual way. The integral of e to the 3x is going to give us e to the 3x, and then using the chain rule we divide by 3. So our answer is e to the 3x over 3 plus the constant of integration. So as usual we're going to do a sanity check, and we're going to differentiate this answer. The differential of e to the 3x over 3 is going to be 3 times e to the 3x over 3. The 3's will cancel, which means that our answer is e to the 3x, which is what we started with. You should now be able to answer the first 6 questions in the textbook, which can be found at this location here. In the next video we'll get on to integration by substitution.